Welcome to qnawire.
All right, guys, we're doing problem 102 of chapter 8 in Chemistry Central Science. One scale for electronegativity on the concept that electronegativity of any atom is proportional to the ionization of the atom minus its electron affinity. You see this equation right here. K is the proportionality constant. As this definition explain why a electronegativity of F is greater than the electronegativity of chlorine. So we're going to start out by just plugging things into our equations. So EF K times 1681 plus 328 equals K of 2009. Where ECL is equal to K of 1251 plus 349 K of 1600. And so you can see that the increase in ionization energy offsets the decrease in electronegativity. So since K is a constant, the proportion we have for fluorine is higher than the proportion we have for chlorine, specifically because ionization energy is increasing faster than and electron affinity is decreasing. So B, why are ionization energy and electron affinity related to the notion of electronegativity? So electronegativity can be thought of as an ability for an atom to hold on to its own electrons and the ability to attract electrons from other atoms in the molecule. So if you have a high ionization energy, you have a high electronegativity because you hold on to your atoms very strongly. And if you have a strong electron affinity, that means you're going to be able to pull the electrons away from another atom because you're more willing to accept electrons into your orbitals. All right, so using data in chapter 7, determine the value of K that could lead to electronegativity of 4.0. So 4.0 is equal to K times 2009, and K is going to be equal to 2.0 times 10 to the negative third. So D, use your result from part C to determine electronegativities of chlorine and oxygen. So chlorine triples that at ECl is going to be equal to 2.0 times 10 to the negative third times 1600, which is going to be equal to 3.2 to E of oxygen. That's 2.0 times 10 to the negative third times 1314 plus 141. That's 2.91. All right. Another scale for electronegativity defines electronegativity as the average of the atom's first ionization energy and electron affinity. Use this scale, calculate the electronegativities for the halogens, and scale them so that fluorine has electronegativity of 4.0. On this scale, what is bromine's electronegativity? So I'm going to just delete this. So we can rewrite this as E is equal to C times the average I minus E plus EA over 2. So let's get our electronegativities. So fluorine, chlorine, bromine, and iodine. So EF. So first let's find the value of C. That's C is going to be equal to 4.0. Oh, and well, 4.0 is going to be electronegativity of our halogen. 0 divided by 1681 minus 328 over 2. So C is equal to 5.9 times 10 to negative third. Third, ECl is equal to 5.9 times 10 to negative third. $12.51 minus 349 over 2. That's going to equal 9. So this is going to be 2.67. So EBR it's going to be 5.9 that's 10 to negative third times 1140 minus 325 over 2. Third, and it's going to be a value of 2.4. Third, so this is going to be 2.4. So for iodine, it's going to be us, and that last one, that is our bromine. So that is part of what our answer. So our scale for electronegativity for bromine is 2.4. So 5.9 times third times 1008 minus 295 over 2. Third, so that's electronegativity of 2.1. So these are the electronegativities of our halogens right here.